Nani? Why aren't you working? Come on, go back. For fuck's sake, get out of here. Alright. Utopia Builder. Story. Utopia. So the controller support seems reasonable, I would say. Which map? Which map? Fractured Gorge, Broken Shore. I don't remember. Could you show me first? Okay, no beacon at all. Fuck beacon. Okay, let's pick Steward. Run. What is it? It was this one. God damn it. Fuck. That's not what I wanted to do. No, I don't want to continue. I want to get out of here. Jesus fucking Christ. Stupid fucking. Okay, I don't want this map either. Not happy with any of the maps, to be honest. Hanging Rock. Pet. Ah, not the citizen difficulty. God damn this shit. Fuck, I forgot.
Stuart.
Just wanna try out the damn controls. It. Thank you. Finally.
Stuart.
Wow. Look at the flickers. Stand city view. Select between selections, okay. Uh, that's the menu. They went with the radial. Council, Explorer, Frostland. Ideatory. Okay. Command radial. Okay. Buildings, Frostbreaker. Ah. This is so-so, to be honest. Mm. Okay, it's not any. Yeah, I think the controls are stupid. Uh, okay. Hmm. Whatever, whatever. Fuck it. I'm not doing this. It's off. Let's do some coding.
Like, I felt like
in the sense they are an exception.
Again.
I know it's super wide, but has to be. So, let's start from the start. I think what I want to do is this part. Hey, it's me. No, not this one, not this one. No. Okay. So let's see game. Let's open that. So what we need, first we need a setup to be able to run Visual Studio. Not Visual Studio, but Terminal. Yeah, I'm not updating it during the stream. We'll do that later. We'll do it live. We'll do it live. Every damn time. All right. So for that, I think we need CPP. PP setup PS1. Copy it here. Have we got it? Yes. So this is what it does. Let's view it nicely. I think I also got this kind of command, or I learned this command from Casey's stream, this stream. Modified it a bit. Yeah. So it finds out where this bat file is, which comes from Visual Studio installation. So under community directory, your version directory, VC auxiliary build, VC vars all. So when you run it with the x64 command, it provides all the variables and then sets them, but this kind of command, it just captures the input here. Then for each of them, we set them in PowerShell, essentially with this part. So that we can use PowerShell. I wonder if I need to do this every time, or can I just set them in the system environment variables? I imagine you can. But why doesn't the Visual Studio just does it itself? Either way, main.cpp, even though we're gonna write C, we're gonna write it in CPP, because we're gonna use methods inside structs, I think. Really? Really? Yeah, I was thinking I have it disabled, like it shouldn't work. Okay. Garbage. All right. So I think I can set the C++ version here. Standard 23. Okay. Really? No, I want to include print. Yes, that's exactly correct. I hate this shit. And I cannot disable it. Where was it? Yeah, see? I can disable the terminal. I cannot disable this. I hate this so much. Okay. I'm gonna ignore it. Can do setup. So I can have the compiler available. I think I don't need any library for this. Oh yeah, let's do the make directory build. We don't need the library. Are we in build? No, we are not. CL ZI. Printer identifier not found. Yes. I think it was CPP Standard 23 preview something. Or let's find out. MSVC ZCPP standard. Standard 23 preview. That's why we are not going 26, because compiler only supports 23, I think. Just told you to do. Ignoring? Ignoring? Are you serious? Do I have to set it before? I think not. Really? Not working. Damn it. I need to look it up. I had it working somewhere. Don't remember where. Yeah, that's what I'm doing. Stud C++ 23 preview. Bruh. That's exactly what I'm doing. Print not found. It was print, wasn't it? Ah, stupid, silly of me. Are you sure still? Thought it was like that. Is stood and is print. What is your problem, mate? Oi, mate. What's your problem? Papa. That's what I'm doing. And I even have a flag. Really? You can print like this? A vector? Wow. Without even specifying anything. It just prints it. Bruh. 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 Okay. Okay then. Damn. Look at that. And look at this. Wow. Really? This is higher than that. Why does it need to be? Surely you can further type on compile time. Okay, either way. So, what is our problem? Why is it being ignored? This is what being ignored, right? How about C++ 23? Still ignoring it. Is your Kapala? Let's check with Grok. Grok. Ah, damn. Yes. Silly, silly me. Okay. Nani? Oh, please don't tell me. Don't tell me I have to upgrade. This is not the time. Hey, Ash and stood standard. Here. 11 or 17. That's it. Nani? Oh, so I have to upgrade. And even then, if it's like available. Yeah. God damn it, this tooltip. Do, 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 do. Okay, this is not helpful. Okay, maybe we can just update it. Oh, at least it's faster. Oh, there's the installer update. Damn. Well, either way, we can move along with this. We don't need this for now. But now we can just do. Was it stood out? This. End line. Was that iostream? Okay. Yeah, we can build it. Main hello world. Perfect. So, where's Mr. Casey Moratori? Ref term, we'll see that later. Con PTY. That is so good to know. That's gonna be interesting too. Okay, let's keep that for now.
Basic things we would expect.
Not this. Alright.
Something directly into a build directory where we can run it, and we learned how to launch the debugger, which is Visual Studio Community 2013 if you have not already downloaded it, and we can do stuff like step into our code and watch it run. This is Handmade Hero. But a message box is not a particularly useful thing for a game to pop up. In fact, if you have seen one pop up in a game, it usually means that the game has encountered a very serious error of some kind. So what we are going to do tonight is try to open a window that is a little...
Okay, let's do the message box first. Hopefully this is visible. Okay. Well, this works of widescreen. At least some of it. So we need include Windows.h sleep 2000. Thank you for the sleep. Why are you complaining? Hash include errors directory, please update include bots. You'll be fine. Don't need that. Was it pragma? Comment lib user 32 was it? These suggestions are kind of helpful. I mean, we are doing very bare minimum, basic template kind of stuff, so. Damn it, that's exactly what I wanted. Okay, message box. Apparently we have to change this to callback, and this has to be WinMain, the Windows main, which is not really a true main, because Windows will call it. I think this is the message and my title window. Okay. And Casey doesn't be okay, and the icon information. Clang format is not available. No worries. I think this should work, right? Or do we have? And I think we don't even need to do this. This cd build. See, man. Sure. I know. Setup. Did I overload it? Oh yeah. Yeah. You need to accept arguments at instance. Previous instance LP string and in and command. Okay. You're helpful. Thank you. No, what? I did not overload it. Cannot be overloaded. See documentation version of WinMain. Yes, I'm not overloading it. Int in the LP string, h instance and h instance. Int callback WinMain. Perfect. Okay, then null was the problem. Now, behold my title window. Dun dun dun. Ah, this is so cool. Hopefully it shows up in the stream. Yeah, this is a beauty. Ah, so satisfying. Okay, just calling some API. So Then I think. Come on.
What we are going to do is we're going to create a special, essentially, buffer in memory that we can write into ourselves and do all of our rendering into ourselves, and then we are going to show how to display that buffer in the window. Now, this is not exactly how is an interesting thing to do in the very, very early days of Windows. The Win class, and you will see that MSDN.
So Win class is
or if you're familiar
everything
with
that you need,
languages.
essentially.
A struct is basically just a record. It's a collection
To manipulate window in Windows.
Are doing is they
A
have
window in
compress all
a
of
window
that
in
into
Windows.
One, very concise definition, which is they're saying typedef struct tag win class, and then at the end of it, after they declare the struct,
So we know how
win
structs
class.
work
No reason
in C.
to
I'm gonna pause this because I've watched this before.
and the rest.
And the 0 is 0 initializing, essentially cleaning up the assignment.
That in there.
And we don't need many things from Win clause.
Kind of few, but in one. All of these
We
things, class, to pick those last indirection to these are. Something in own DC are both things that we sort of need to be aware of for what we are doing. And
Okay.
anyway,
I think we only need a clause. It still matter. Alright, anyways. Let's follow along. Window clause. Oh yeah, that's exactly what I wanted, but name it window clause. I'm gonna name my variables lowercase or camel case. Damn. I mean, I want to accept it. That's very helpful, but I will not. We're gonna do it ourselves. Do it ourselves. Okay. Window clause. Follow what Casey is doing. Style. Here draw. And vertical draw. Horizontal draw and vertical draw. Oh, okay. He's saying check if horizontal draw and vertical draw and on DC still matters. And he's doing CS on DC. What was it again?
On some stream when we're just going through and doing I always specify. We basically have CSH redraw and CSV redraw are flags that tell Windows get so fast. It's a device weird system, but that's how it works. And
I look at the unique device context for each window in the class. Yeah, very helpful documentation. Seriously. A unique device context. What's the device? Is that the system that I'm running? That's the context? I guess. Well, whatever. Let's move on.
Flags do is they basically say, look, I'm going to be doing a bunch of graphic stuff. I don't want to deal with any overhead that there might be with sharing these device contexts for when I want to draw things. So class DC says, I want my own device context for any window that's created with this window class. And own DC says, I want my own DC for every individual window. Now, that's technically the one that we want.
Okay.
I'm going to go ahead and put that in there. It's probably not necessary these days. Computers are so fast. It's kind of old school to ever specify that. But I'm going to specify it anyway because, you know what, for old time's sake, let's go ahead and specify it. And what that basically means is we will not have to get and release DCs for our windows if we don't want to, because we always have our own DC that we can just use.
Okay.
And class DC would basically have done that same thing because we're only ever going to create one window with this class, but it's kind of a little disingenuous because if we were going to create another window for some reason with the same window class, we would want it to have its own DC as well. All right. We basically have CSH redraw and CSV redraw are flags that tell Windows when it needs to repaint our window, like when they are dragged around to horizontally or vertically. And honestly, I haven't thought about those in a long time. You know, reflexively, I type this pretty much I always specify those, like redraw the window when it gets moved around. But you know, I've never really thought about whether I still need them anymore. So maybe that's something that while we're on here, I'm going to go ahead and put a little marker in this code. And you can see I have a thing in Emacs that highlights anytime I type to do, so I can kind of see where it is. Let's go ahead and highlight that and say, check if hredraw, vredraw, ownDC still matter. Because we could go in afterwards. It might be fun on some stream when we're just going through and doing some
On DC,
we might want to go ahead and check
horizontal
and see,
redraw and vertical
how
redraw.
important any of these things even are anymore, or if they're just old things that I always do.
Window
because the way I posted them,
plus,
and that was
and then
so, all
LP,
these other things like sends double-click messages. You know, you can look through here and you can see all these sorts of things. Save
LPF,
bits, which tries to
LP
restore
function
these
window
old, like,
proc.
most of these things are just antiquated, and you don't really need to use many of them. We may not even really need to use the ones that we're even using. But anyway, there we go. We have a window class name. We have our instance filled out. We have our flags filled out. So the only thing we need to do now is actually define a window procedure. And this is the thing that will handle all of the messages coming from Windows, which I'll show you what those are in a sec. That pertain to us. Okay. So what is that?
Long pointer
How would you have known what that was
class
if I wasn't here to tell you? Well,
name. My
here's
window
an
class.
example of, again, how MSDN can help you. If you
My
WinProc, you will
beautiful
see
window class.
to the window procedure. You must use the call window proc function to call the window procedure. For more information, see window proc.
Okay.
If I go ahead and click on window proc, you will see that it actually defines exactly what the procedure is right there, which is what I wanted to know. And so what I'm going to do is I'm going to go ahead and cut that out. This is the callback, which is the phrase callback is exactly what it sounds like. It is a thing where Windows calls us back from its code to have us do something for it.
Can I
And you can
disable
see,
these? What the hell
right
is
here what the parameters are to it. It gets passed an hwind, we don't know what that is yet, a unsigned integer. It gets passed a wparam and an lparam, all totally mysterious to us. We have not really dealt with any of these because even the unsigned integer, which we now know is just an unsigned 32-bit integer, we don't know what it means. So what we're going to have to do is look at MSDN and see what that stuff is. But for now, we know that this is our main window callback. This is the callback that will be called anytime we have a window of this class that Windows needs to send something to have it do something. And we'll see a little bit more about that in the future. So what I like to do, and this will probably...
main window callback. Okay. That's what we need to define. L result, long result. Be callback. No, the callback. Main window callback. Window callback. And it had HWND, totally makes sense. HWND, and it's an unsigned int, uMessage, and then wpram, white pram. White around pram, and then long pram, half pram. Okay. And that we're gonna provide here main window callback. Another point. It's automatic. Okay, anyways, what's your problem? Value of const char cannot be assigned to LPC white string, aka const white char. I know previously I was complaining about it, but I ran some code and it worked. Okay, we're gonna ignore it.
Probably frustrate a lot of people, so it's just what I like to do. You don't have to do it.
Right.
I hate all their little prefixes and weird names. As far as I'm concerned, this is instance, this is prev-instance, this is command line, and this is show code. So I'm just going to go...
Okay, yeah, I'm gonna do this too. This is stupid. but I'm gonna keep them lower. They keep, yeah. Yeah, that I do not like about but Casey is using the variable names. Just use camel case, dude. Show code. Okay. Perfect. Yeah, it's pretty. Okay, what do we do?
Flat
What
out rename those things because I don't like to look at their weird naming convention any more than I absolutely have to. And the same is true up here. I happen to know what these things are,
Okay.
so I'm going to name them what I want to see them called, which is message, window,
Okay.
and then just changing the capitalization scheme there. And what you need to understand here is that function signatures in C and C++ are really only about the types. A
Yes.
function signature, the definition of that function, only depends on the types that you're trying to pass it. The hwin, the uint,
I know.
the param, that part. The name of the parameter is up to you. So even though Windows is the person who's calling us, it's only the fact that it receives these 4 specific things that are important. It does not care what they are called. So you can change them to be called anything that you want, whatever you want them to be called. Literally any name here is fine, so you should name things whatever makes it easiest for you to read. And that is what I like to read, so that is what I have called it. Now, if we go in here, we can see the definition of these things. Basically, we have an hwin, which is a handle to a window. Hwin stands for handle window, basically. And what that is that's just a opaque thing. We cannot really look at it at all, but it is an opaque piece of data that we can pass back to Windows that allows it to know which window we are talking about. So it passes it to us and says, hey, here is the window handle. If you need to talk to me about your window handle, just go ahead and pass this back, and I'll know what you mean.
Okay, then name it handle window.
Simple there. The uint, the message. So basically what this is the message that Windows is asking us to handle. It is going to call us back with a variety of different things.
Message.
And what we need to do is we need to go look at what those things are. So system-defined messages, here is the list. And basically, as you can see...
We go back. W-param. Additional message information, the content of this parameter depends on the value of the U-message param. Okay. Why are they called W-param and L-param? Additional depends on, yeah, doesn't really explain.
So system-defined messages,
Okay.
here is the list. And basically, as you can see, over the ages, it has grown to be absurdly huge, the number of things that you can receive. Now, most of the ones that we care about are not these kind of things. Animation control messages, combo boxes, all this sort of stuff. Since we are not going to be using Windows hardly at all, we are basically just opening a window and then we are doing everything else ourselves, most of the things that we care about are very simple, basic window operations that we need to respond to. So they all fall under the WM category, and we will not really need much from anything else in here. A lot of these things are for if you want to use the Windows standard controls, such as track bars, the task, like these sorts of things where you see like Windows standard controls, buttons that you click on. If you want to use their standard controls, they all have special message codes that they will pass back and forth to you and stuff like that. But we're not going to be doing any of that. If we make a button, we'll be implementing it ourselves, so we don't need to call them. So we are going to be dealing in here. And at first, basically what we need is just our window messages. Excuse me. So I'm going to go ahead and look in here and see if there's anything in particular that we want to handle. I think we basically want just like a few simple things. Yeah. Okay. So the ones that I think we want to handle at start here, and I'm going to use the switch statement that I discussed in the intro stream. The switch statement, of course, allows us to take any value and switch to see basically if it equals any constant that we want to input. So here I am going to use these codes, which are defined in Windows, to be constants. They are specific numbers, basically, that will be used to say which message is coming in. And I am going to field, for example, the WM size command, which is when the user changes the size of the window. I am also going to field probably the WM destroy command, which is when Windows deletes our window. And also perhaps I will field the WM close message, which is basically what happens when the user clicks on that little X up in the corner of the window. And finally, I think I may also do, just at the beginning here, I may do activate app, which is basically a thing that lets us know whether the user has clicked in us and we are the active window or not. And now you'll remember I also said back in the intro stream, if the thing that we are switching on does not fall into one of the constant categories that we have defined using case statements, we can go and actually use default statement to catch up all of the extra slack. Now, what you are seeing here, probably for the first time, because I have not used this in the intro stream, is the way that I write case statements, which is a little unusual. The way I like to write case statements is I like to actually put a basic block in there, just define my own block. That is not required. That is the normal way that a case statement out to the other. That I would
To scope everything to the block, otherwise they're scoped to the switch statement, not to the case statement.
We'll just turn it on.
But yeah, that's the point. Sorry, I watched it before. Output debug string. So why am I using? What's your problem, mate? It is. Stop complaining. So this will be destroy. If I can type, this will be close, active, active app, default. All right.
In a second, we won't turn it on at first. So if you remember from the intro stream, output debug string is basically just a call that allows you to output something to this window over here, this window right here. It will show up in the debugger, we can watch it, and it's a good way when we are just starting a Windows program and we do not have anything implemented, we cannot really log anything, we can't use any of our own debug services that we may have written to do debugging. It is a good way to kind of bootstrap things because it will be a nice little place to print things out as you go, and you know that that code got executed. So, now, you'll notice that there is an L result. An L result is returned from this. Okay, and what an L result is an L result is basically just a return code. It's something that we return back to say what we basically did with the message. So each one of these messages, Windows has certain meanings that it will assign to what we return. And if you look in MSDN, you can actually see what those are. So you go in here, and it'll basically say, if an application processes the message, it should return 0. Right? So basically what that's saying is if we actually handled the message, which in this case I suppose we did, we should return 0. So what I'm going to do instead is I'm just going to set result equal to 0 and assume that we handled the message. Because the next thing that we have to do to finish our window procedure is we have to basically do a catch-all to handle all the messages that we don't handle. And in there I am going to assign result, right? I'm going to assign that return value, and I got to obviously return the return value here eventually as well from the function. I'm going to assign to that return value basically the result of calling Windows' default window callback, which they have defined. And what that basically is it's a catch-all that says if you don't want to worry about particular messages, you can call me and I handle all the messages in whatever the default way is. So it's basically like saying,
nice.
Okay, I am sort of the first person on the food chain for these messages. My main window callback will be the one who looks at the messages and goes, is it one of these 4 that I care about? But if it's not one of the 4 that I care about, I can go ahead and pass it on to Windows and let it do the default behavior. And as you'll see, we may actually even want to do that for some of these messages and other messages we might handle in the future. We may still even want to call the default window procedure even when we do handle a message, because we may just want to do something extra than what it does, if that makes sense. So the default window procedure is documented in all of these things, basically, and it's just called def window proc. You can click on it and see its definition, and as you might expect, it looks absolutely...
By the way, I should have linked this in the stream. I'm gonna do it now. I should have done that before. And we're gonna pin it. There you go. And pin. All right.
Identical to, well, that is if my internet is still working. Let's hope that it is, since we've been having problems today with it. Yeah. I need to get some kind of guaranteed internet so my screen can't be interrupted if that's possible. Anyway, the default window procedure is literally exactly the same function signature as ours, only instead of it being a callback where Windows calls us, it is a win API, which means that we are calling it. Now, callback and win API, I mentioned them a little bit in the intro stream. They are a decoration that specifies a calling convention. We have not gotten to calling conventions yet, so I'm going to kind of defer talking about what those are for a little while. But otherwise,
Right.
you can see that it's exactly the same. It returns an L result, which is basically just, again, it's just an
How do? Is it also in the same header?
unsigned
Sorry.
integer, I believe, is all, or it might be a signed integer. Let's take a look. We can actually
Def
take a look
window
at
proc.
what L result is actually defined to be in the Windows headers. So inside here, Windows data types, it does look like it's signed there. Come on, MSDN, you can do it. I know you can return it.
Or you can go to
So if
definition,
you
your
go here,
editor.
Windows data types, it will actually tell you what they all are. And you can actually see the pound defines that
So,
specify
N64.
the actual literal value of these things. So if we go to an L result, you can see that it's defined to be a long pointer. Okay, that is not what I was expecting it to be, but I guess they want you to be able to return pointer values in there, which means it will actually potentially be 64 bits on our device, I guess. You know what?
It is.
Since that's interesting to me, let's pause for 1 second and let's take a look. Let's see what's going on here. Size of L result. Oh, you know what? I don't even have to do that here. We can just go ahead and kind of pause what we were doing, right? All of this should still be valid code. Looks like valid code to me. So let's go ahead and build that. Everything builds fine. And I'm just going to go exploring. So we go in here. This is our, well, you know, I don't even think I need to do that. Let's go in here. Let's see if I can take it the size of it right here, or if it's because it's a pound defined. Yeah, there we go. So size of L result returns 8, which, as you remember, it's all in bytes, so that means 8 bytes, which means 64 bits, which is exactly what we thought when we saw long pointer. So basically what they've done here is they have said, okay, main window callback returns something that is 64 bits, and that way they could return, probably the reason they're doing that is because that way they can return anything, any single value that they want to, including a pointer to something, which, because we are compiling in 64-bit mode, you remember VCVARS32, we called, in fact, I can show you right here in the MISC, shell.bat. Remember this little guy here, compiling in 64-bit mode? Well, that's what that means. Since our memory 64-bit address space needs 64-bit pointers, so we'll be getting to later because we don't actually.
Yeah, it's Win64. Otherwise, it would be
Since
some
Windows
other
wants us to be able to return
type.
our pointer size, it needs full 64 bits there. Even if we don't use the full 64
Unsigned
bits
in.
messages, it needs to be big enough to handle the return value of the biggest message. So that is good to know. I think the last time I really seriously thought about window procedures, it was still in 32-bit windows, and those were 32 bits long. So hey, they're 64 bits now. The times, they are changing. So we are going to go ahead and call def window proc. It is just a pass-through, and we are going to pass it the exact parameters that we were given. We have no idea what they mean. We don't care. We figure it will figure it out. So all we will have to do
Handle window
for these messages. So
message.
all right.
W
So now we'll compile
param,
this, make sure we haven't done anything wrong.
L
Everything is
param.
fine, no errors. And what we're going to do
And
now
wait
is we're
up.
actually going to open a window
not
using
messages,
the window class.
message.
In order to do that, we of course have to do what's called registering the window class. So the way that works is we
Okay.
use a thing called register window class or register win class. I don't remember the thing. Let's take a look here.
Register window
Spelling of register win class. Register window
class.
Register class.
Register class.
Register
Okay.
class. That's what we want. So
Okay.
I was wrong in both guesses. Register class. We are going to go ahead and register class.
Does that take a
Register class
reference?
just takes a pointer to our window class, the window class that we are trying to register. Now you notice it returns something called an atom. And you may ask, what is an atom? Well, an atom was just something that was used in the old days. Windows,
Do I need it?
they're still around, but you almost never actually use them.
Oh,
They're basically things used in Windows to sort of mementoize, to like remember a particular string value or value you wanted to refer to again. And in fact, I don't know if I can find an actual, let me see if I can find an actual thing to show you here, where you just register an actual atom. Let me.
Can we compose? Oh,
Because I think
compose. Perfect.
I dig deep into the
And main?
Let's take a look. Query cancel autoplay.
Nani?
I think that will show us.
It didn't show anything.
Example of
I thought that was it.
Let's take a look.
We register the window.
Yes. So here was a typical one, for example, that I remember being an atom-based thing. If I am not very much in error, is it not? No. All right. Darn. All right. I do not know then. I do not know a good example of something where we're still going to use an atom.
Okay.
Racking my brain. I'm
No
sorry. I can't
worries.
think of it. Someone in the chat probably knows, and it really isn't that important, so we're not going to dwell on it for now. But point
It's
being,
okay.
we probably will not see atoms much at all. You used to use them for things like, and like I said, we're not going to use these, but you'd get an atom back if you wanted to register a named property that you could associate with a window and other things like this. But we have no need for any of that stuff, so racking my brain again, but I can't think of anything. Thought cancel autoplay might be one, but I can't think of anything that we're going to do besides this one call that actually uses an atom, and we're not even going to use the atom. We're just going to register the class, and that's all we're probably going to do. So we go ahead and register this window class. Registering the window class technically could fail, and so we could check to see whether when the atom comes back, at least I think that it could fail. Let's take a look. Function of seeds, let's see. The function fails, return value is 0. So technically, if we want to, we can just double check to make sure that this succeeds. It never actually in practice fails. But if it does, if we want to start being correct, once we actually build a nice little logging system and an error system, which we will be getting to later on, we may want to log that. Why not, for complete mistake? I don't know how we will ever test it. Probably, I guess we could test it by registering the window class twice, because I think maybe it would fail. Nah, it would probably just return us the same atom again. Well, I don't know. We can try. Anyway.
Okay. No worries.
Once we register the window class, we can then create something of the window class. We can ask it to create a window for us, and this will be our window handle. We can call create window, and create window is a function that will create a window of some class that you specify. Now we might want to specify extra things to it, so there's actually two versions. There's the old version, which is create window, and there's a new version, which is create window EX, which has a few more parameters. So we're going to use the
So register window doesn't really create the window. We created the window class.
We are going to call that, oops, there we go.
And goddamn even registered it.
To create our window. So here we go. Create
That's annoying.
EX, there we go. And we are going to fill out, much like we did with the structure, even though this one is not structured. You know what, I'm just going to go ahead and do a rectangular kill there to get rid of all of those guys. There we go. So I'm going to use this to basically create the window, and I'm going to pass it all of the things that it asks for. Now, extended style is another one of those bit fields like we saw up here.
Create
or
window.
that tell you what style you want. I don't think we want any of those styles just yet, but we can double check in here. Here's extended window styles that we can go in here. Again, MSDN being so slow is a real bummer. It is kind of slowing down the stream in an unfortunate way. So I'm actually going to sort of preload a few of those here. Okay, here we go. So the extended files, accept files if we want drag and drop. We don't really want that. Top level window in the taskbar, client edge, composited. I don't really know. Paint all ascendants from bottom up order. Doesn't really seem like there's much here we want. We are not layer window. We don't need left alignment, scroll bars, M to no activate, blah, 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 blah. I don't think we need any of these right now. So we are just going to pass 0 as the extended style. The class name is, of course, the class that we just registered. So we're just going to go ahead and straight up pass it out of the struct that we had filled out before. The window name for now is going to be Handmade Hero until we have some other reason for changing that. And now we get to the actual window style, which we do want to specify. And there's a whole bunch of things you can say, like whether or not the window has a border, whether it has a caption on it, all sorts of things like this. But we probably don't need to worry too much about those because there is a aggregate style that basically just creates a default window that has the standard stuff that you usually want to have on it. So we are just going to specify that, which is an aggregation of all of these different flags that we might want to use, right? All good. So we're going to do that. And the other thing we're going to specify at the moment, which we may retract later because we may want to create it invisible first and then do some shenanigans, but we are also going to specify WS visible because if we say otherwise, it may not start visible. I don't remember if
overlap window.
Some interaction with the flags actually will automatically be visible when you create them, but normally when you create a window, it is invisible and waits for you to show it. and we are not going to quite do that yet. So now we can pass x, y, width, and height for the window, and what we are going to do there is we are actually going to pass this special value called CWUseDefault. Normally you would actually specify the coordinates on the screen that you would want to do, and we don't want to really talk about coordinates just yet because that is something we're going to talk about later. So we're just going to pass useDefault, which just says open this window on the screen anywhere that you want to. And I believe we can do that for the width and height as well.
CS useDefault.
So that will take care of it for us. Parent window is if you want to have windows inside windows
I think that's not a thing.
on the screen that you would want to do, and we don't want to really talk about coordinates just yet. This
Yeah, it's not CS, CW. It's CW useDefault. For X, useDefault, and what's for Y? It's also the same. Okay.
special value called CWUseDefault. Normally you would actually specify the coordinates on the screen that you would want to do, and we don't want to really talk about coordinates just yet because
200, maybe
we're gonna talk about
200.
later. So we're just going to pass useDefault, which just says open this window on the screen anywhere that you want to.
And
I believe
handle
we can do that for the
parent.
width and height as well. Yes, we can. So that will
Handle window parent. Do we
Parent
have
window
a?
is if you want to have windows inside windows, which we do not want to have, so we do not need to do that. We can pass a 0 for that, and it will assume that we are just a top-level window that is on the desktop. We do not have a menu, so we don't need that. We have an instance, so we're going to go ahead and use that instance.
We are not.
Have windows inside windows, which we do we're going to talk about later. So we're just going to pass useDefault, which just says open this window on the screen anywhere that you want to. And I believe we can do that for the width and height as well. Yes, we can.
Alright.
So that will take care of it for us. Parent window is if you want to have windows inside windows, which we do not want to have, so we do not need to do that. We can pass a 0 for that, and it will assume that we are just a top-level window that is on the desktop. We do not have a menu, so we don't need that. We have an instance, so we're going to go ahead and use that
Okay.
instance. And we do not need to pass anything to our window. There is a way that you can basically pass a parameter to the window. If you were to pass something here as this last parameter, it would basically come in during a message called wmCreate that comes in here. Oops, if I can spell properly. wmCreate that comes in here, and you would get that value if you wanted to do something special with it. Okay.
Okay.
So, this is basically all we need really to start up, and if we check our window handle when it comes back, we can see down here in the return values, if the function sees the return value is a handle to the new window, if the function fails, return value is null. Now, null happens to be equal to 0, so we can actually just do an if on the value, and that will be the same as checking for null. Some people love to actually type the word null all the time, just in case null changes from being defined to be 0 to be something else. I don't love it, so I don't. But if you are the kind of person who really cares about something like that, you would type this.
No, I'm good.
But we're not going to do that. Okay.
But,
Same thing here. This will almost never fail in any practical circumstance, but if we have a nice error handling system that we will develop in the future, we may want to start handling that. So I'm going to mark that with a to-do just so we know there's something to do there. Now, once we get in here, we have one last thing to do before we will show our window on the screen, and that is that we need to start a message loop. Windows does not by default start sending messages to your window unless you actually start pulling them off of what's called a queue. And the way this works is anytime you have an application in Windows, it creates a queue of messages for you that essentially starts filling up with messages that Windows is trying to send you, or anyone else who's trying to send you a message through the Windows system for that matter. And what we need to do is we need to loop through our messages, and we need to extract them so that we can send them to our window. And the way we're going to do that temporarily is we're going to use that with the getMessage function. Now, what the
See, I
getMessage
have
function
clown
does
format.
is that basically allows us to pull messages off of our queue. And if there are no messages in the queue, it will just sit there and wait. Now, it takes a pointer. Again, I don't know if you remember me discussing in the original stream that basically Windows likes to use Hungarian notation. So LP means long pointer. So instead of writing this, which would be much clearer in the function signature, they write this and make you have to know that P means pointer. It's annoying, but that is the way Windows works. So this is just an MSG, which is another struct that we will look at in a second. And that is an MSG pointer. So we are going to take the address
Is it formatted? No. What the hell? This is stupid. Didn't I have that somewhere? Client format. I am getting distracted. Yes, we are. Was that this client format? Yes, it was. And it is installed. So what's your problem, mate? Can we reload it? Client format command is not available. Please check your client format executable, user settings, and ensure it's installed. Manage extension. How about settings for this extension? Extension, client format. Yeah, that's the one. What you want? What's your problem? Uh, executable pod. There you go. You happy now? Okay, now it's working. So I just want these to be on the new line. Search this. I know I'm getting distracted. I'll do it in a bit. Format each param on new line. Break before parameter line after open braces. I'm not sure if it makes sense, but let's try it. Nani. What is your problem? Why are you opening this? Don't open it. Break before parameter true. Unknown key. Bruh. Underscore. Seriously, I thought that was a very easy question for LLMs to do. Like, it must be ubiquitous at this point. Client format settings. Bin back. Yeah, that kind of makes sense. This is good. What about this? Do we have intelligence? Line ending. Yeah, that's already what we have. Column 11, 120. Okay, that is good. A bit too long. Maybe 80 was better. Okay. What about these? Bit back from. Okay, okay. It's the same. How do you guys? Bin pack parameters. Dude. That's already what it is. Reload window. Okay. That's not, it's not working. Maybe this. No. That should be easy answer. It's just a search. You just need to look up what relates to what. How is that a problem? Bin pack parameters not working. Line after open bracket. I want it on a new line. God's sake. Okay. Too much time on this. I'm gonna move along. Okay.
That and pass it to Windows so it knows where to put the message that it retrieves. We are going to pass the window handle. Well, actually, you know what? We're not going to pass the window handle because if we have any other windows or messages not bound, we may want to get them. So we can actually pass 0 for that, or null, which will retrieve messages from any window that belongs to us. So that's kind of handy. So we'll just grab all of the messages that are coming in. And these two filters here, filter min and max, are if we're only looking for specific kinds of messages, which we're not. We're looking for all the messages that might be bound for our window because we might want to process them. So what we can do there is we can pass essentially dummy values to that to make sure that we get all of them. Let's see how that actually works here. I forget the magic indentation. User value specify first messages. Use W if you are both 0. Get message returns all available messages. So basically what we want to do is just pass all zeros to this function essentially, and that will be what we want to do.
Really?
Now,
Not the window
we
handle?
want to keep going. We want to be doing this for a very long time. And as you can see, it says, if the function retrieves a message other than wmquit, the return value is non-zero. And wmquit is the thing that would basically be someone's posting a message to our application telling it to exit. So what we would like to do is basically keep running until getMessage returns false, right, if it wasn't a wmquit. Now, this is not exactly how we will use our message loop in the future. So this is a little bit of a stand-in. So don't take anything I'm saying here too seriously because, yes, you can see this here. The possibility of a -1 return value in the case that h1 is an invalid parameter means that such code can lead to fatal application errors. Instead, use code like this, and you can see that they've written it here. This was the thing that I was referring to. Now, we're actually not going to be using getMessage, so we don't have to worry about too much about this. But at the risk of somebody like looking at this and doing the wrong thing, maybe we'll just do it like this, just even to start off on the right foot. But like I said, we won't actually be using this in the future. Oh, it looks like I've got a... Oh, I did it again. I said I would never use Miratori4 on the stream. Sorry, didn't mean to do that. All right, there we go. There's our for statement. So we are going to go ahead and take a look at getMessage here. It's funny that it says bool, but it says it can return a -1. It's kind of fantastic, right? Yeah. What are you going to do, ladies and gentlemen? But basically what we'll do here is we'll say this is the message result that we're going to get. Back it comes. And then we will check on the message result to make sure that it is above 0. If it is above 0, then we will handle it. Otherwise, we will break out of our loop here and exit. So that should be fine. Now I'm curious to know what they actually define bool to be. They must define it to be a integer type of some kind because
Then 0, then go here, otherwise I'll break. Okay.
loop here actually define bool to be Boolean somehow, which it obviously can't be because that wouldn't probably work in old school C.
I think it's unsigned in.
Then we
Kind
would
of.
not be able to test it for a negative
We can
value.
check it.
So I'm assuming
I can
that's
go
fine,
to
even if
definition.
We don't need to look it up right now. The point being,
Oh, it's just int.
actually some kind of an integer that they define there. All right, so we are going to check here. If we get this, then what we have to do
I thought it would be unsigned in.
actually translate and dispatch
Meh.
this message.
Okay.
Now this is total Windows minutia. Basically what it does is translate message is a thing that turns keyboard messages into more proper keyboard messages. We do not have to worry about this at all right now, but we will have to think about it a little bit later because basically what we have to do is we have to field keyboard messages in the future, and we will want them to be translated properly. Now, for games, it may never actually matter, but I'm going to stick that in there anyway. So ignore this for now. It's a thing that basically takes a message that came in off of the message queue, does some processing on it, and gets it ready to actually
Damn,
send
can I
it.
type?
So here we go, back to dispatch message, the function that will actually send messages two windows that have them, and you can see it's just a thing that, again, actually dispatches the message. Now, these things technically return error codes, but we have no way of actually handling the error codes. If Windows did not want to dispatch one of its messages, there's nothing we can do about it. So there's probably not much point in actually checking these. We could exit the application, but that seems like a little draconian just for failure. So I'm not sure what we would do there. We could log it. Maybe we could log it in the future, but I don't really even know if that's necessary. So this will go ahead and loop forever until we get back something other than a positive result from getMessage. Let's go ahead and compile that. We have some undefined errors, undefined code there in CSU's default. So for some reason that was not there. Why? So I got that straight out of create window, did I not? So I wonder why that was not recognized. Did I spell it wrong or something? Let's find out. So I wanted to pass it's CW. I used class style. That's up in here for CS.
Yeah.
I was like CS owned to C. This is CW, which is I guess for window. Create window, let's say. I don't know. Who knows how they name things, but they name them. So there we go. And if we go over here and run our program, well, I've got to unset that breakpoint first, but you will notice that we finally have a window on the screen. There is our lovely window. And if we go over here and look at the debug output, you will see that we...
Damn it, I forgot how he started the debugger.
Style, that's up in here for CS. I was like CS owned to C. This is CW, which is I guess for Windows.
He showed in previous streams, I forgot.
I don't know. Who knows how they name things?
Okay, there's a build.
Things, but they name them. So there and if we go over...
Okay, it's already loaded there. I think the command was dev environment. I'm loading, still loading. No. Okay. Dev and main.exe. Can you load that? Do I need to? No, I don't need to define anything. This off. Use your Copilot. Thank you for that recommendation, but didn't I compile it with the flags? I thought I did. Yes, I have. So it should have compiled information, but it's failing. While trying to match the list of arguments, line 53. Really? This Casey Moratory for loop. Four? What's the problem? Or do I have the line wrong? 54. Okay. Yeah, getMessage. Message reference, which is of type message, and then 3 zeros. That's exactly what I did. Ah, it's a message not reference, pointer. Why do I keep saying reference? It's a pointer. I know it's a reference that creates a pointer. That is the pointer. So this I. Alright, now let's compile. Success. Success, Messiah. Can you step in? Hey, we got source code and everything and stepping in. Perfect. So go in there. Zoom. No, what the hell are you doing? I'm saying zoom. There's zoom. Oh. 200. Too much, maybe. 150. Okay, reasonable. Autos. Can you guys move over there? Yes. And you too. Okay, perfect. Nice, nice. I'm rolling. Da da da. Dee 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 da 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 da. Okay, that's a nice window. My great window. That's a great window. Can't close it yet. We were going to default and then close. Is it upside down? I think not. But yeah, we have log messages anyways. Alright.
Let's say, I don't know. Who knows how they name things, but they name them. So there we go. And if we go over here...
That's a lot of setup.
Well, I've got to unset that breakpoint first, but you will notice that we finally have a window on the screen. There is our lovely window.
So we register the window, register the class. We created the class, register the class.
WM size, and that was because as I go ahead and drag...
And then we create the window and we tell it class name of the class that we registered. That's how it knows.
WM destroy message no matter what we do, because that would have to come basically from something that was going to forcefully try to close the window.
And we say overlap window visible.
So there you go. We have a window on the screen.
And default for the size and size.
Is we would like to draw
an instance.
Just to prove that we finally have a window that actually has
program that we are talking
about. The way
about.
that we can do that is we can field a message called WM paint. So inside
Wait, but how does this get message know what we are talking about? Which window are we talking about? Oh, yes, because we didn't provide that, and he was saying let's get messages for everything that we can. Yes. That's kind of weird that they do that, but sure. Okay. Power, I guess. And then we translate the message for keyboard to something to keyboard. So it's well formed, and then we dispatch messages. Forgot, why did we need that? So we get the message and dispatch the message so that our window callback can get the messages. That's so weird. Who designed this API? Seriously. All you needed this thing, dude. I know historical reasons and blah blah blah, but like, what the fuck, dude? Just create a class, I guess, and then call a window. Call back on that. And then maybe if you want to register, kind of have that API, sure, do that. And then we're done. What the hell is the rest of this stuff? Stupid, all that one. Okay, now we want to paint. Okay, we paint. And it was WM paint.
WM Paint. There we go. We are going to use that DC thing that I was talking about. So basically, what we can do inside WM Paint is we can go ahead and ask Windows to allow us to paint to our window using their graphics API, because on Windows, if we're painting to a window, we have to use it. And so what they have is they have a thing called Begin Paint and End Paint, which allow us to say we are about to update our window. Here it is, right? And then we are going to go ahead and use End Paint to tell it when we are done. So here we go to end. Oops, it was right there. You can just click on it. End Paint. There it is. So we are going to go into End Paint. There we go. And we're going to pass that window handle that we got here. We're going to pass our window handle. We are going to pass the address of a paint struct.
Okay,
right?
let's not do it for now. I was going to take it out, but papa. Paint struct. Paint. And then we have to do HTC, really? That's what it returns, but we don't need that. Do we need to return? I don't know. Begin paint. Window. Handle window. Da-da-da-da. Satvir Gill. Hey, dude. Satvir Gill. Nice name. Thanks for the follow, man. Handle window. And then we need the handle. We need window and then handle. I thought that was the handle window. What the hell was this? Maybe we define 0. Hey, I think we put 0, so it's the default handle, I think. And paint. Okay, so we are painting. I'm doing great, dude. How are you doing? We are watching Casey Morituri and following his Handmade Hero series. That's what we're doing, because I didn't like Frostpunk. I was going to play Frostpunk, but then wasn't in the mood. Yes, let's follow along if you want to. Do you code?
Paint that it can fill out for us. And
Yes, I do. Oh, I linked it in my... Yes, I do. I do speak Punjabi. Satvir Gill. Are you... I'm trying to guess. Are you sick? I think that's a sick name, isn't it? Satvir Gill. Yes, I'm sick, but I'm mixed race. Oh, really? Sick and what? What's your other half? My other family is Swiss. Ah, nice. So Swiss and sick. Lot of S. Nice. So I guess you're watching from Switzerland or Germany.
Turn one of those contexts for us. one of those device contexts. So let's take a look at the documentation of that so we understand what's going on.
Okay, we get device context from Begin Paint. Why do we need that? HDC device context. Yes, I'm from Switzerland. Nice. I'm in Germany. Nice, we're nearby. So you grew up in Switzerland? Or India? India or Pakistan, I guess. Oh no, actually, sorry, I'm wrong. A Sikh diaspora, actually, they are in quite a different places in the world. There are a lot of Sikhs in Thailand, long time ago. And obviously nowadays in Canada. Yeah, so actually could be anywhere.
Going on. Inside Begin
Text.
Paint, we pass it the window that we are trying to paint right here.
Okay.
Handle to the window to be repainted.
Damn it. Why am I passing the third argument then? Oh, I'm completely wrong. Handle window. Why did I do this? Alright, Begin Paint. We need a handle window. I guess that's our... Yeah, that's our handle window. I mean, I've been to Pakistan too because my mom family was from there, but in 1947 partition. So they came from Pakistan. Ah, nice. So most likely from around the Lahore area. That's very nice. I was near Salcott. Ah, okay. Yeah, that's the same, almost the same area. Yeah, more precisely, Salcott. Yeah. Nice. I was living there sometime in Lahore. Yeah, it's a nice city. I just have a lot of this in my life. Yeah, now you're starting to see it. Salcott. That's fun. Okay, so this is good, this is good.
And we pass it a pointer to one of these paint structs, which is another one of these structs that Windows uses to pass information back and forth. It's passing it out to us this time. So what it's going to do is it's
So do you program or you're just watching just chatting stream?
which tells us where we need
Not
to
sure if you joined because of programming or I should actually fix the title, fix the category. Should be software something. Come on, software development. Yes. Why is it just chatting? I was just chatting. Okay. But what did you? Are you a student?
thing which says whether or not
Paint
it was
struct.
erased, this sorts of stuff. Whether it's an incremental update, those sorts
Yes.
of things. We're not allowed to test those.
Nice.
Those
What are you
not in the
studying?
System, as you can see here, labeled that way. But we are going to go ahead and field that in a relatively...
I want to guess. Something. Okay. Okay, I wasn't guessing that. I would have guessed something related to finance or data science, engineering, or something like that. I've just recently met, or not recently, a few years ago. I was working near university, so I met a lot of students going back and forth. the Zoom. And most of the people I met, it was just like, yeah, we're doing data science, or we're doing finance, something data science. I'm like, why is everyone doing data science? What's up with you guys? Apparently, it was very famous recently in this area. Nice psychology. Very nice.
Straightforward way. So we're going to do that, and then endPaint, of course, just takes the window and the paint struct back so that it knows which, just basically to close off the paint. There we go. So,
but I'm doing real estate, side by side preparing, so I can do houses and can get money under the table. Nice. That's a good plan for sure. Yeah, it's psychology. Suppose it's not gonna be good money that much, as much as you can get under the table. Under the table is always a lot of money. Because it doesn't matter what.
all we are going
We
to
just need to find those
we are going
tables.
to do a patblit. A patblit is a function which basically just tells Windows, it's sort of a graphics utility, which basically tells it to do blackness or whiteness or do some kind of another bit operation to things. So we just want to fill our window with white for now. That's going to be a very simple thing for us to do, just so we can see that we are painting to our window the way
Okay,
that
let's
we
do
want to.
patblit.
Okay, device context passes the device context that we're painting with. It takes the the size of the window, right, which we already actually, well, we do know what it is. I'll show you what it is in a second.
Okay,
And then eventually
handle
it takes a flag that says,
window.
sorry, a value. These are constants, right? Whiteness, blackness, DST,
It is the device
in
context.
the Windows.h and sorted header
It was
file.
nice meeting you, bro. I have to go. And
Fill
okay.
it should do to
Thank
the
you, dude. Thank you for
rectangle
hanging
we're
out.
going
See you
to
later.
occupy. Now, what is the rectangle?
Ciao,
Well,
ciao.
fortunately for us, we actually know what the rectangle is because we got it back from Begin Paint. Remember when I said inside Begin Paint, there was this paint struct here, and this paint struct basically tells us what we need to know. The RC paint, if you go down and look at the documentation for that, is a rect structure that specifies the upper left and lower right corners of the rectangle in which the painting is requested, right? So we basically have in here, after we do that, we have a rectangle. We can go paint, RC paint, like that, and we can access its members. Now, what are the members of a rect? They are what you might expect. The left, the top, the right, and the bottom positions of that rectangle, right? So min and max on X and Y. Again, don't worry too much about coordinate systems. We'll be covering them in the next stream, or approximately even the stream after that. And they are longs, which are just yet again another definition for int. Windows has a ton of definitions for integers, depending on what size they are or what exactly they correspond to. But these are basically just integer values, as we will see when we step into this code. So when we did patblit, let's go back to patblit. When we did patblit, oops, that's the one we actually want. There it is. It needs a left, it needs basically the left, the top, and it needs the width and the height. But we didn't have the width and the height. In our rect structure, we have the right and the bottom, which are maxes. So we have to subtract right from left and bottom from top to get that width. We want to see how big those are. So we're going to have to do that, right? We're going to have to do bottom, like this, minus top, right? And we're going to have to do right minus left in order to get those widths and heights that we wanted, right? Oops, backwards. Height is going to be that one, and
the paint is the reference. I missed that. Okay, let's do this. Long height. Paint. RC paint dot bottom. Okay. Pen RC pen top. Yeah, that will give you height. And width would be the x coordinates, which is will be right and then left, right? Left. Okay.
width, right? And then we already know what our x and y are, right? Because we already know that our x is this. And you know what? Should probably pass the ones that Patblit wants. Those are longs in there, but they're defined as ints here. So we might as well convert them out to ints. Like I said, Windows has so many definitions for ints. It's kind of a rat's nest, and most of it's historical at this point. But what are you going to do? We have the x and y for the rectangle that we want to paint. We have the width and the height, so we can go ahead and do it. Width, height. There we go. Nice and clean. See how we compile. Patblit. Well, we know how to deal with this, right? Taught you on the last stream. If an import symbol is not defined, we go down to the bottom here. We take a look at who it was, and we grab that library. gdi32.lib is what...
Is it X? Oh no, it's left on top.
Who it was, and we grab that library. gdi32.lib is what we need for Patblit. So we are going to go into our build.bat and stick it on the end. There we go. Compile and done. Now when we run, we should see a white window, ladies and gentlemen. Pretty nice, huh? It's lovely. Totally lovely.
X, Y.
That is the best white window that I bet you I've ever seen. Now just to prove
Width,
how awesome we are,
height,
because you know that we are,
and what the hell was that?
Why don't we just...
whiteness.
Sometimes we'll paint it with black, and sometimes we'll paint it with white. Because there was blackness, and there was whiteness, right? So what I could do is I could look at
white.
Here, go up here, and this is just a little amusing diversion.
What was the library we needed?
So what we're going to do here is we're going to take our D word, which is our operation.
33.
We're going to assign it to whiteness, right? But I'm going to use the static keyword. Now what the static keyword is normally every variable is local to us.
Sorry, just a sec. How am I missing something? This is here. Okay, paint to Timotium. What the hell? I'm missing closing brace. Seriously. None at all. Line 33. Closing brace. You can't be serious. There's your closing brace. What else do you want? Can we try again? Okay. Somehow that was a problem. Maybe it wasn't saved yet or something. Unresolved symbol. I know this and this. And what was the thing that he linked?
Us.
Damn
the
it.
static keyword is.
We can look it up. WinDGI. Okay, let's add it. WinDGI. Does that work? Kinda. Can't open WinDGI lib. Okay, maybe that header is somewhere else. No. Windows API Paint. No, begin Paint. I could have just Win user. Is that? Which library is it? Library user 32. But I had that before. So which symbol is missing? That's the one. Patblit. Reference function, this and this. It's not resolved. Okay, let's see Patblit. Library GDI 32. Okay. Perfect. Does it have to be capital case G? Ah, no, it doesn't. Perfect. Nice, nice. Okay, it's white. It's white. Yeah, previously it was going. It was changing color. Now it's not. Perfect.
Is normally every variable is local to us, right? Every variable is local to where we defined it. Remember I said these blocks, these braces, the variables are local to us. But what I'm going to do is I'm actually going to say, you know what? I want this variable to persist. I want you to create it, and then I want it to stick around. So that when I come back through here, it will actually be set to whatever the value was the last time we ran this thing. So it's basically creating permanent storage, essentially a global variable. It's almost like we were to declare it out here as a global variable, but unlike a global variable, it is locally scoped to this area in terms of lexical. Like it's lexically scoped, meaning that we can't refer to it anywhere else. So it keeps it kind of contained, but it is global. Now, I never, ever, ever, ever use these. They're a very, 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 very bad idea. Code that I actually need to ship. But I always use them when I am debugging, because it's very handy to be able to stick something in really quickly that is there. And this is exactly what I'm doing right now. I just want to debug something to make sure that we are actually painting our window every time. So I'm going to use one now. But I never use these basically because they create nightmares for thread safety and all sorts of other stuff. So we will see a little more of that later. But don't do this willy-nilly. This is something I'm only doing right now for debugging purposes. So basically what will happen is the first time we come through here, when you see this static, what it will do is it will initialize operation to whiteness, but the rest of the times through it will not initialize it. Only the first time through will it initialize it to whiteness. The rest of the times it will just leave it at whatever value it was. So what that means is we can, every time we go through here after we do this, like this, we can go and say if the operation was whiteness, right? Remember the if statements from our intro stream. We can then set it to blackness. And if it was not equal to whiteness, we will set it back to whiteness, which will basically create a toggle. So when it comes through here and it's set to whiteness, it'll turn to black. When it's set to black, it'll turn to white, and it'll toggle back and forth and back and forth and back and forth. Right? Good. We hit run. We get our white window, which is what we expect. We then drag it, and there we go. Don't know if the stream can keep up with that, but we are basically creating a epilepsy window that just to demonstrate when we are redrawing the window. Pretty good for one night's work at only an hour. So hopefully that is enough to tide you over till tomorrow, when we will field these messages a little more appropriately, and we will actually create a bitmap that we can blit to our window, which will take it up to the point where we can actually start to use it to render our game, which is what we need. So I hope that was a good enough, quick introduction of how to get a window onto the screen. Within the space of an hour, there's only so much we can do. But we will be going through tomorrow and fleshing this out in more detail and getting a nice proper window that we can actually use for rendering our game in good shape. So thank you so much for joining me. I will pause the stream now, and we will go ahead and answer
How do I close
as soon as I toggle the recording.
What the hell? How do I close it? Okay, end task. Alright. Alrighty, alright. So now it's black. Yes, and because we changed the event, it goes white, black, white, black, white, up. Okay. And how do I kill this? Alt F4 doesn't work either. I have to end task. Okay. Alright. We gonna skip on what is my PC? Ah, damn it, it's not working. But this is working. Q&A. We're gonna skip that, and we're gonna go to lesson number 3.
Day 2, which is the day before this. Unzip that, translate them, and
So I think I'm gonna take a pause and do it afterwards. See you guys, I guess, in a few hours or 1 hour or something. Well, we don't know